Hello. How's the midterm exam? Is it very hard? Okay, let's have a look of the exercise 1. Okay, don't worry too much if the midterm exam is very hard. Usually we don't have enough time to do it. So, as I mentioned last time, we only have around like 12, like 60% in the average score. So most of the student cannot get like more than 60%. So that's totally fine. Don't worry too much about it. So let's just focus on the assignment and the labs for this week. We will have some help session for the assignment this week. I think it's in Thursday and Friday. So you can come to the session. We will introduce how to do the coding for the important function in the assignment. And yeah, let's have a look of the exercise 1 here. So all we need to do is just download this stuff. I have already done it. So let me share my screen on the Wireshark. Just download the file and then you will see this. So the first thing you want to do is in the preference, set the sequence number to the, just change the value of that, of the TCP. Yeah, just in the setting, you find the TCP and unselect this part. So we don't need the relative sequence number for this part. So just make sure you do this before you do the exercise. Otherwise, you will get the wrong answer. So unselect this and press OK. Then double check on the sequence number. So in your Wireshark, you may not have this one. So let me delete it. And I will teach you how to apply a new column. Just select a random TCP packet and then find the sequence number and then right click it, apply as a new column here. This one. So we can add the column for the sequence number. And what's the first question? It is, what is the IP address and what is the port numbers? And the second question is about what is the post segmentation number and the post sequence number. So the IP address is basically in here in the destination. But before you do it, you may need to check what is the host of that. So make sure you find out the correct IP address. And the port number is also in this part, in the transmission control protocol here. So you can see the source port and the destination port. The destination port A0 will always be the HTTP service. And then for the post, the second question, it's about the post. You can check what is the content, what is the payload inside the packet. So you can look at this part. You can see this one is the POST. This is the payload. And next packet is about the content type. You can see we divide the HTTP request into different TCP packets, right? So we can consider this one is the first one because it contains the first line of a HTTP header. So just use this one in the question. And what's next? Next one is to calculate the RTT, estimated RTT. In here. Maybe just open the lecture slides and search RTT. We need to find the equation first. It is in here. So we are going to do the calculation for estimated RTT in here. So, and let's go back to the Wireshark. Just copy this equation and go back to the Wireshark and see what we need. The first thing we need is the estimated RTT and the sample RTT. So we need to figure out which part is the estimated RTT and which part is the sample RTT. We already know that alpha is 0.125. So just come back to the Wireshark. This is the first packet. And we need to know the time. So we need to write down the time in here. Let me open Excel so we can do the calculation. Okay, so we use Excel to do the calculation. The first one, maybe it's the sequence number. And the second part, you can put the time sent. And the next part is the time act. So we need to know when did we send the packet and when did we receive the act acknowledgement, and what is the sample RTT, and what is the EST RTT. So that's our table. You can put this one in your report. We just need to fill in the blanks. I would do the first 3 rows, so you can check how did I do it. So we need to know what is the sequence number. If you look at the line 4 in Wireshark, it should be something like this, 9013. And the time is 0.026477. And next one is about the time act. So you need to look at the act for this packet. You can have a check. How did we figure out which one is the act? So basically, you just need to look about the act number. And this is very important to figure out this number. And the sample RTT will equal to this one minus this one, which is 0.02746. And because this one is the first row, so the estimated RTT will equal to the sample RTT directly. So paste as a digit. Where's the digits? Just value. Yep. So let's try to fill the second row. Second sequence number, which is the row 5. Let me copy the value. And by 578. And the time we send, which is this one. And we need to find out the acknowledgement time. So we need to have a check of the acknowledgement number one by one. Yep, I found the packet, which is in here, this one. And so the sample RTT, we use the same equation, this one minus this one. And the estimate RTT, then we need to use the equation from the lecture slides. We will be equal to 1 minus, so 1 minus 0.125 times estimated RTT, which is the previous value, and then plus 0.125 times sample RTT, which is this one. So that's the value for that. Is that okay? So that's how we got the value. You can see I use the equation in the Excel here. I think the hardest part for this one is to figure out what is the act time, because you need to have a check. What is the sequence number for that? You need to check the packet one by one and figure out the time of that. So I will just do the first two, then I think you already got the idea. The equation is pretty simple to use, but it's pretty hard to find the acknowledgement in here. Just get it right. Do we just start at a random sequence number? No, we are starting at this one. Let me share my screen. In here, you can see it does specify which packet are we using here. So just read this paragraph. Then you know we have to use that packet. This one. So you just put the Excel table in your report. I will also upload this one to my GitHub link, so you can simply download it and use it. Next one, what is the length of each of the 6 TCP segments? So maybe just have a check in the Wireshark. This one is pretty easy. So what is the length? It should be inside here. I didn't see it. Like, do you have any idea if we can find it in this part? It's not the payload, but it's quite similar. So I guess we need to do the calculation by ourselves. Let me check how can we do the calculation, for example, for the first one. So I guess we need to add a column in here in the table. So in here, we can add a length in this part. Let's have a look of the first package, 9013. 9013, this one. And we need to figure out what is the length. So I need to find the acknowledgement package for this one first. So how did I find it? I just basically looking at the ACK number in the other package. So it's 9013 and the length is 565. So we should know the acknowledgement number should be, do some calculation based on these two, right? Do you have any idea what will be this acknowledgement number? Yep, so it's pretty easy. Just because the sequence number is 23212913 and plus the what is that date? The length 565. Right? So it's 578. That's the reason why the sequence number here is in this value. And we need to find the ACK number for that. 109013. I think it's this one, right? So that's the acknowledgement for that. We just need to double check of the value. Is that correct? So these two. The first one is the data we sent from our computer to the server, and the next one is from the server to our computer. So can you check? This one is the correct ACK. Yeah, just simply do the calculation based on the sequence number plus the length. So the sequence number plus the length of this one, which is 565, will equal to the ACK number. So that's how I found it. And so I just use this one in the question 3 as the ACK time. And next one, we need to do the calculation of the length. Just the same idea, right? Just the ACK number minus the sequence number in here. Yeah, just this one. But we already know that the length is 565. So you just put it in the table. We don't even need to do any kind of calculation. Just look at it in the information column. And it is 565. So the table will looks like this, 565. And the next one, we just look at the next packet. I think it's number 5, and it specifies 1460. And the other one should be quite similar. Just look at the information column. And that's it. Okay, so we come to the last one. We need to calculate what is the throughput. So we are in here, the throughput. I will skip this too, because it should be pretty easy for you to figure this out. It's not about the calculation. You just have a look of the Wireshark itself, then you can figure out the answer. And let's talk about the throughput calculation here, the byte transfer per unit time. So in order to calculate the throughput, we need to figure out how many bytes did we send in total in the trace file. So we need to maybe look at the end of the file and look at the start of the file and do some calculation and figure out how many bytes we sent. So explain this in your report, and let's just have a quick look of how to do the calculation in here. Let's just open the first one, the Wireshark. So which packet are we looking for in here? Do you have any idea? So maybe just scroll down to the bottom, and which is the last packet? Is it this one or this one or this one? Or this one? Any idea? Which one is the last one? So let me figure this out. So we are trying to get the last packet in this trace file, but it doesn't mean we need to select the last one like in here, right? Because this one is the thing. It's not about the context. So we may need to choose another one. So you can have a look. I just give you a hint. It is around this area. Yes, I can see someone get a correct answer. Someone got it. So you just choose the package as the end of it. And then we need to choose the first packet and do the calculation. And we just scroll down. We already find the last packet. So where is the first packet? Which one is the first packet? Okay, it should be in here, right? We already know that because it is the beginning of the post request. So we use this one because the first two is the same and same MAC. It doesn't contain any kind of data. So we consider this one is the beginning, and to somewhere at the end of it. So you can consider this one is the end. I'm not pretty sure. Maybe you need to double check and explain in your report. And just do the calculation. It's pretty easy. So how can we do the calculation? It's just the acknowledgement number, right? The last one is the acknowledgement and minus the first sequence number. So will be the length of the data. So that's the data size we have sent from our side to the server side. And what is the time? What's the difference between the time? So you can look at the time column. So 0.026477 minus this one, 5.45580 will be the time. So use the data size divided by the time, then you get the throughput. So it should be around 0.3-ish. No, it should be around 30 kilobits. Okay, so let's go back to here. The next one is the just the pure calculation based on the TCP connection. I think you already know how to do the calculation because you attend the midterm exam. You just do some calculation based on the ACK number and the sequence number. Let's have a look at the first one. What is the sequence number of the TCP scene segment? Yeah, so sequence number you can find at here, right? So pretty easy. Let's just scroll down a little bit. So this part, this kind of question. So in order to do the question 3, 4, 5, maybe we need to draw something out to figure out what happened in this table. So I recommend you to draw something in your report like this. Let me share the whiteboard. So I think you can draw something like this. The left-hand side is the client, right-hand side server, and just specify left-hand side IP address. The source IP address is, what is that? Give me a sec. That's 0.9.16.201. And this file is 0.99.6.175. And then you can draw the communication between them. The first one is the same packet and the same NAC. So we can specify what is the number for that. You can specify 295 same and 296 same NAC, something like that. So let's just keep doing this. I will not finish it, but you can do it by yourself. Let's just come to the end of it. Which part is the end of it? It's the 304. So we just skip something between them. And then we come to 305 here. We see there is a packet from which file? Sorry, it's 304 actually. So it's 304, 304, this one. It's a thing, which means we want to finish the TCP connection here. So just from 201 to 175. So from left hand side to the right hand side. And what's next? It is 305. It's from the 175 to 201. So it's right hand side to left hand side. So is the thing act again. We can draw like this. Is thing act 305 and in the 306 you can see is the acknowledgement for the thing. And it's from 201 to 175. So in the 306, you can see the acknowledgement for the thing. And from 307, you can see it's also an acknowledgement from right hand side to left hand side. So what do you think about it? Like for the end of the connection? I just made a small change in here. You can see in the 304 it's also thing act. So if you go to the TCP part and then you find something wrong with it about how can we close the connection. So let me just share my screen. So this one is not the correct answer because based on the lecture slides in here, you can see in order to close the TCP connection, we only need to send one thing from whatever the server side or the client side and one ACK, then we can close it. We don't need to send two things, right? FINAC. So what happened here? You can see this one is from the client side to the server side. So if you come to here, then you can figure out what happened. So you can see these two, they both send the thing to each other, then both send the ACK. So it's like this. They simultaneously want to close the connection. So they both issuing the thing command to each side. And then they receive it and reply ACK and then close it. So we call it simultaneous closure. And let's come back to the drawing we have in here. So maybe we need to change because this part is not correct, right? So if you're comparing about this ACK number, then you figure out, oh, it's not correct. So we can draw like this. This will make more sense. So they issuing about the thing commands simultaneously, and then they reply the ACK one by one, like this. So that's the second exercise. Let's have a look. Exercise 3, we don't need to do the submission. You can use the network simulator to play it by yourself, and we will have some like exercise. We'll need to use it. We will play around with it next week. Don't worry too much. It's just like a new programming language. Not much people are using it right now. Just you try to understand the syntax. I think we do have a new slide about it. So you can have a look of the slides, or you can do a tutorial online to learn how to use it. It's pretty easy, just a simulator. We just need to type some code and just simulate a kind of situation and see what will be the throughput and what will be the internet connection status, like that. We will look around about it next week. I recommend you to do this part by yourself before you do the next week's stuff. And let me know if you have any question about exercise 1 and 2. Okay, we got a question here. One for question 1.8. So I guess this one, right? Let me share my screen. Is it this one? The throughput. We just calculate the end sequence number, the start sequence number for both client and server, right? Yes, I think so. You need to calculate them separately. So I only calculate this client side, didn't calculate the server side. Let me just explain it again, maybe make it more clear. So in order to calculate the throughput, we need to figure out which packet is the last of it. So for the client side, I assume this one is the last packet. You need to do your own research. Which one is for the server side? So now let's assume this one is the last packet. So I have a look of the time here is 5.45530 and minus another time. So which one is the first packet? It's in the question 3. We know it's already know it's in here because we send the post request in this packet. So you can see the time 0.26. 0.026, sorry. So we do the calculation based on the time. And what's the sequence number? We just minus this one by this one, right? So just do the calculation. Oh, sorry, it's the calculation based on the ACK number in here. So you can see it's 2322933103 minus this one, minus this sequence number here. So we know we have sent this much bytes. Then we just divide the results of the data by the time. If I didn't get it wrong, I remember the number is around 30 KB. Yeah, and you can do the calculation from the server side to the client side, vice versa. Should be the same idea. Yep, I will stop the sharing and stop the recording right now. Let me know if you have any trouble. And thanks for coming. Didn't expect we had this much people today because we just finished our midterm exam.